Moin! This video is part of a scientific Python programming lecture at the University of Bremen, and in this video we would like to talk a little bit about packaging and how to make a Python package out of our project. As always, you can find the slides to the lecture on the website of the lecture, and basically this is part of lecture number 10 about packaging, and we will deal with two things, with the modularization via packages and talk a little bit about private and public variables. So basically the point is what I would like to do. We would like to do something which we already know from the third-party packages. If you think about the os.path package, you remember that basically here I have a kind of dot notation because there is a package os and then there is the package os.path. Let's have a short demonstration of that. We are working in our usual Ubuntu environment, and let's just start, for example, here just IPython3. And if I'm just you remember, if we wanted to manipulate paths, we were just importing the os.path module, and then we had to, for example, if we wanted to join two paths, os.path.join, and then we had basically path 1 and path 2, as you remember, then it was just join the two paths. And the point is that here we had something big. It was the os package and the sub package of that, the path set package, sub package, and we had to here to basically separate the two of them by a dot. And we had to import the os package, os.path package explicitly. However, this is not necessary. We can do it also otherwise. Let's do the same exercise, but now only import the os package. And it turns out if you just import the os package already, then you can use os.paths. Then I have path 1 and path 2. And that works also nicely, right? os.path join, of course. Join we should not forget. And if you add join to that, that works also as well. So basically we could either directly import os.path or import os and have automatically access to the special module os.path. And this is exactly what we would like to do with our project. And I will use for that the linsolve project, right, at a certain stage. And if you remember of a linsolve project, this toy project for solving linear systems of equation, then we have here a script file which basically uses the capability of our library, which contains of two modules, solvers and linsolve.io. And here you see already there's a good reason why I didn't call the module IO, but I was adding here the name of the project and calling it linsolve.io. And the reason for that is because the Python itself has an IO module, and it's not very nice if you are defining modules with the same name as the modules in the standard Python distribution. Although it may work, however, it depends a little bit on how your environment is set up, which one of the two is found by Python first. So it's usually a much better way to avoid collisions. However, it's very difficult to avoid collisions to all different packages because, of course, many different packages could be there which have their own IO module. And therefore, it would be much better if we could here use the explicit name. So, for example, we could say similar to os.path, I could say import, let's say linsolver.solvers, and let's say linsolvers.io. Those two things here, okay? And then of course if I would here invoke them explicitly, then I would have also to write here linsolver.io to be more specific. Also that would be linsolver.solvers.gaussian, and here to the IO module would be inside the linsolver package, and here also inside the linsolver package. Okay, no, here I think the line is too long. Yeah, indeed. Then let's just break this line so that everybody is happy. Now the big question is, does that work? So I have linsolver.solvers and linsolver.io has been here imported. Now if we just try to make it work, and then we are just testing that .linsolve, then of course it doesn't know because it doesn't find the name module linsolver, which would have the sub-modules, the package linsolver, which would have the sub-module solvers. And this is in Python very, very easy to create packages and sub-packages. This is basically just creating directories. So I will just create a directory linsolver. And basically I will just move the two files, the linsolve io.py into the linsolver folder and rename it in io.py, and I will just move the solvers.py file into the linsolver folder. And then basically even also if you look up here, the structure in the project explorer, you see that here I have no package directory linsolver with the files io.py and solvers.py. In order to tell Python or indicate Python this is to be interpreted as a package directory, it's very custom to create an empty file init.py in the same, but of course not in this folder, but in the linsolver folder. So if you go into the linsolver directory, you have the two modules, and the file indicated that Python should treat this directory as a package directory, and basically that means everything which is here there should be treated as sub packages. Now we can test whether our approach works. So we are just executing linsolve, and then basically you see that it went much farther. Here before it was already failing at the linsolve. Here at this point at the import, now the import has worked, and it fails because it doesn't find the input file, right? But for example, I could just make here the test python3 and the -m pytest if I want to make the pytest testing online here on the command line. And okay, it didn't work. And why? You see, because in the test module I was trying to import the module solvers, but of course some module solvers doesn't exist. So we have also to fix, of course, our tests. So we are talking about the test solvers module here, and then import solvers. Instead of solvers I have to use let's say linsolver.solvers, and in order not to have to rename everything, just or rewrite everything down there, let's just import it under the name solvers, and linsolver.io under the name io. And now let's try to make the tests again on the command line, and here I still have something. Test solvers, it has not been saved. No, it has been saved, and if I writing it now, all the tests are fine. So basically I just created a package directory here, and this works out perfectly. So basically we accomplished the first part. We could make or let's say our namespace, you can also call it. So basically all modules will now have the name linsolver.name of the module. So even if we name our module io, it will not conflict in Python's io module, because it must be imported as linsolver.io. And also here the same way. Now I have shown you the trick with os.path. Was another trick with os.path. It was possible just to import the upper package and then get access immediately to the lower packages. So basically in our example, that would be it would be nice if I could just import linsolver and then basically getting access to the submodules linsolver.solvers and linsolver.io. And let's try whether that works out at all. If I'm now just running the code again, then it fails again because it says the module linsolver has no attribute io, so it didn't work out. Now how can I do that? And this is exactly where this .init _init__ file comes very handy, because this is, first of all, it indicates for Python that this directory should be treated as a package directory, but you can also insert code here, and that code will be executed if somebody tries to import the package as well. So not the sub packages with linsolver.io, but somebody tries to import the linsolver module itself, exactly as we do it here. And what would we need in order to be executed if I'm here importing this module? Then it would be good if that import would trigger two further imports which were executed here explicitly. So basically what we can do is just take this and here insert there, and basically in order to be in the same namespace as solvers and this, I will just call it as io, and we can test whether this approach works now. And I can just start linsolve, and again you see basically it was running through and through the imports without any problems, and failed just because of the missing input file. And you see here I have only an import linsolver. And basically, just to be sure that on the safe side, we can just write the PyTests again, and all the tests are still working. So basically, also the old way of importing is what is written here, where I'm importing explicitly here the two modules is also works. And if you just import a package, so linsolver, then basically this init.py is executed, and therefore those two modules are automatically involved. And as solvers, why as solvers? Because here, if this this init.py is executed, I'm already within the package linsolver. So basically the name, all the names which are created here would be already prefixed by the linsolver dot from outside. And therefore I have to rename them to solvers. Otherwise I would have to write linsolver dot linsolver dot solvers, which would be of course not the right thing to do. So basically that works as well. And with that, you are able to make packages, Python packages, and I would always recommend, if you make something which consists of more than one Python modules or several Python modules, just make a package for that and basically put your Python modules within that package. Then you have basically you are, so to say, safe from colliding with some names which are used for third-party modules or even for Python distributed modules. The last thing which we should care about that is what should packages or modules in general export. And basically here you see that already. I was following the convention that entries which are starting with an underscore in Python are considered to be private. Private means that basically whoever imports that module is not supposed to change those values because they are only used within the module. Also here in this old version of the project, we had some internal routines like the make partial pivot, which people were not supposed to call from outside. It's just a helper routine for the main routine, which is the only routine which this module is supposed to export, the Gaussian eliminate module and routine. And basically this thing is just a helper function. And this is not supposed, the users are not supposed to call it from outside. Okay. And the same way, this tolerance is something which is an internal value for the Gauss elimination routine, and the users are not supposed to deal with that. And we are expressing this privateness with an underscore. However, I would like to emphasize that this is just a convention. It cannot be really enforced in Python. So basically, if I'm just running IPython and then I am just importing linsolver. And then it also imported linsolver.solvers, so linsolver.solvers, and then I can just print the tolerance. So I have access to that. If I know it's there, I have access to that. And even worse than that, I could even change its value. So basically, it's possible in Python, and to say linsolver.solvers.tolerance is equal, instead of 10 to the minus 12, let's do it 10 to the minus 6. And then if I'm printing it again, it was basically changed. And this is something you should never ever do. So basically, because the module, the linsolver solvers module, relies on the right choice of the tolerance constant, and because it relies on that, it was declared as a private variable, so users from outside are not supposed to change it directly. And if you change it nevertheless, then basically it may be that the program doesn't work properly as supposed. Also in theory, I could just execute linsolvers I could just execute the make partial pivot. For example, here I could just execute the make partial pivot with some arguments. Again, this is supposed to be an internal routine, and you should not call it. So basically the bottom line here is private entities are marked by an underscore, but basically this underscore marking, of course, is just a convention. However, you should always stick this convention. Mark everything which is private with an underscore. Actually, mark everything with underscore which is not necessarily is exported. So basically in this module, whatever defined, the only thing this module would like to expose to the outer world is the Gaussian eliminate, and everything else which you declare in this module on the global level should start with an underscore to make sure that people realize that and also Python tools realize that it's a private variable. Okay, so it's very important. Okay, and with that, basically, we finished here the example, and you know a little bit about how to create packages, and also how to hide what is the convention to hide your variables, and whenever it's possible, hide everything and only expose what is really necessary. Thanks a lot of your attention. Take care and stay safe. Bye bye.